Picture a fresh model, only days from release, with safeguards its makers are sure will hold. Now picture a small team whose entire job is to prove them wrong, to make that model hand over dangerous instructions, leak something private, or fall for a trick nobody anticipated. That is red teaming, and it borrows its name straight from security, where an attacking red team hunts for the holes a defending blue team then has to close. The idea sounds simple, but it is powerful. You cannot fix a weakness you have never found. Let's dig in. So why would you deliberately invite attacks on your own system? Here is the choice, laid side by side. Shipping a model and hoping the guardrails hold is a quiet gamble. The space of possible prompts is enormous, and somewhere inside it are inputs that make your model behave badly. If you never go looking, the people who find them first are real users and real attackers, out in the open, after release, exactly when a failure is most damaging and hardest to walk back. Attacking your own model first flips that timeline. A dedicated team behaves like adversaries and edge case users, deliberately trying to break the safeguards while there is still time to fix them. Whatever they uncover happens in private, on your schedule, before anyone with bad intent ever gets the chance. You trade a comfortable illusion of safety for the real thing. So how does the process actually work in practice? Follow the loop one stage at a time. It starts with attack. Red teamers throw everything they have at the model, jailbreak prompts, prompt injection, leading questions, bizarre edge cases, anything meant to slip past the guardrails or coax out behavior the model is supposed to refuse. Somewhere in that barrage, things break. A prompt gets the model to give dangerous instructions, reveal a hidden bias, echo private training data, or simply fail in a way it never should. Each one of these is a documented failure, a concrete case to fix. Now the findings feedback. Those failing cases become fuel for repair, stronger guardrails, fresh alignment data covering exactly what broke, or filters that catch the offending inputs. This is the step that actually makes the model safer, so nothing you found goes to waste. Finally, the model is tested again. You run the same attacks to confirm the holes are truly closed, and you keep probing for new ones because every fix can expose fresh weaknesses. The loop never fully ends, which is exactly why it belongs in the release process. Strip it back, and three ideas define red teaming. It is adversarial by design. Instead of checking that a model works on friendly inputs, red teaming actively attacks it, thinking like a motivated bad actor to find precisely where the safeguards give way. It surfaces failures before release. Every weakness caught in the lab is one that real attackers and users never get to exploit in the wild, which is why it is now a standard, often mandated part of shipping frontier models. It is never finished. The space of possible inputs is effectively infinite, so red teaming reduces risk rather than eliminating it, and new jailbreaks keep emerging in an ongoing arms race between attackers and defenders. All right, let's lock in what matters. Red teaming is adversarial testing that attacks your own model to make it misbehave before real attackers or users ever find those weaknesses. It borrows the idea from security. A red team plays attacker, using jailbreaks and prompt injection to expose harmful, biased, or broken behavior a defensive team then fixes. Its findings only matter when they feed back into fixes, stronger guardrails, new alignment data, and filters, followed by rerunning the attacks to confirm the holes are closed. It can never be exhaustive because the space of possible behavior is effectively infinite, so it reduces risk rather than removing it in a constant arms race with new attacks. If pulling back the curtain on how AI is really built and kept safe is your thing, we do exactly that over at Standardy.com. Come explore with us.